In our previous lecture that you watched, we talked about how to make a solution with a certain concentration, and we were talking about molarity. And if you have a chemical that's a dry chemical, you can figure out how to make that solution by calculating how many grams you need. You could weigh that out on a balance. You could put it into the volumetric flask and dissolve it up. But sometimes you don't have the chemical as a dry chemical. You have the chemical and it's already in solution, but you want to make a solution that's less concentrated than the one that you have. So I can go back into the stock room and I can pull off the shelf an 8 molar solution of some compound, but I need a 1 molar solution. So I need to dilute it down. So dilution is not a concept that's foreign to most people. You add water to dilute out chemical cleaners or orange juice to make a solution to drink. So we're going to talk about calculations with dilution. So let's consider the concept first, okay? So that's what I was just saying. Sometimes you have a high concentration, you're trying to make a low concentration. You add water to do that. It's called a dilution. It's easy to recognize you're dealing with a dilution if you read the problem and it says something about you're starting with a high concentration of that thing, you're making a lower concentration of that thing. Or you read along and it says you're adding water to it. Or you're reading along and it actually uses the word dilute or dilution. You know that's what you're dealing with, okay? So we know that molarity, and let me come right on the screen here. Molarity is moles per liter, okay? We've talked about that. If I were to take this equation, and we were kind of writing it this way, equals moles over liters, I could solve for moles. All right, so what would that give me if I solve for moles? Well, that would give me molarity times liters gives me moles. Or I sometimes just say molarity times volume, realizing that volume is liters equals the moles. And what is that moles of? Solute. So we kind of have to keep track of what that is moles of. But this is, whenever you take the molarity of a solution and you multiply it by the volume, then you would be left with the moles. If we worked with our units, molarity is moles per liter, volume is liters, and that also shows me that we would be left with the moles. So let's imagine this picture here. What's happening in this image? On the left, what we have is a beaker, and the green balls that we see in there represent the solute, and then the rest of it is the water surrounding it. As I go from image A to image B, what I'm doing is I'm adding water, right? So we think, as we add water, what is changing? Well, is the volume changing? Certainly, we can see that there's a whole lot more in image B than there was image A. Is the number of moles of solute, the green balls, is that changing? Well, you might want to stop and verify, but the number is not changing because we didn't add any of those, we didn't take any of those away, we just added water. So those aren't changing, but is the concentration changing? If you look at that and you think of concentrations, moles per liter, our liters went up. If our liters are going up and it's in the denominator, what's happening to the concentration? Well, it's going down. So between these two flasks, what do they have in common? We just listed all the 3 things. Do they have the volume in common? Do they have the concentration in common? Or do they have the moles of solute in common? Well, it's moles of solute that they have in common. All right, now we had on the previous slide, if you knew of this flask right here, its molarity, and you knew the volume of this flask, what could you get for that thing? Well, you could get its moles. If I knew the molarity of this thing and I knew the volume of this thing, I could get its moles, and they have to be the same. So what this gives us, since molarity times volume gives you the moles, this gives us a little equation that we can use anytime we're doing a dilution. And I very often, instead of doing I's for initial and F's for final, I'll just warn you of this because I'm so used to it. I use 1s and 2s, so same thing, initial and final, because I know that molarity times volume will give me moles of solute. I know molarity times volume will give me moles of solute. I know the moles of solute are the same in these 2 flasks, so that is the formula that I use when I do a dilution. Okay, now, big red letters, exclamation points everywhere. This is a dilution formula only. I don't care if you get around a TA who uses this for something else. They're not supposed to. I don't care if you go into a laboratory and they pull out this formula for some other world. It is a dilution formula only. People will sometimes, and you will be tempted sometimes, to use this in other environments besides dilutions. Don't. It's a dilution formula only. Now, what is a dilution? When do I pull this out? I'm reading along in a problem and I'm starting with a concentration of high, some kind of solution of high concentration. I am taking it to a lower concentration of that same substance by adding water. That's a dilution. That's when this formula will apply. So what you have to do, it says to enter. We're in class, what I have is people clicking in on this, so you're not going to enter anything. You're just going to raise your right hand and you're going to promise that I promise never to use it for any other type of problem, even if I think it's a shortcut to that problem by using it. You're not going to use it. All right, so you've just promised to me. I haven't watched you raise your right hand and repeat after me, but I hope you did. Just hope I made a big enough point about this that you only use this for dilutions. Okay, so here's a problem. How many milliliters of water are required to dilute? Oh, there's that word, dilution. I get to use my dilution formula. To dilute 205 milliliters of 1.15 molar HCl to 0.81 molar HCl. Notice how the concentration is dropping down there as we add water. So let's turn to the light board and let's work through this problem. Formula, dilution formula, M1V1 equals M2V2. Okay, I read along and I see that I'm starting with, they're giving me the V1, I'm starting with 205 milliliters of it. They're giving me the M1, it's 1.15 molar. They're telling me what I'm diluting it to, so they're giving me, what the new concentration is supposed to be, 0.81. So this is the one thing in that formula that I don't know, so let's solve for that. M1V1 over M2 equals V2. Plug in our information. M1 is 1.15, and I'm going to go ahead and be good and write it as moles per liter instead of a capital M, which might prompt you to go ahead and put volume in liters here. I'm going to show you, you don't have to, all right? You can if you want. It won't hurt anything. But for V1, I'm going to put 205 milliliters, okay? For M2, I'm going to go what the new molarity is supposed to be, 0.81 molar. Oops, but I'm not going to write it as molar. I'm going to write it as moles per liter because it's a really great idea to always do that. But notice how it's these units canceling with these units, so it wouldn't matter what units I put in here. I could put quarts in there for all I care, or gallons. And since it goes in as milliliters, it's going to come out as milliliters, and this will give me a value of 291 milliliters. Now, is that the answer to the question? The question says, how many milliliters of water are required? Is that milliliters of water? No, this is the final volume of the solution. That's what V2 means. This is the final volume of the solution. So I took 205 milliliters of that solution to begin with and diluted it to become 291. So how do I figure out how many milliliters of water I have to add? Stop and think about it if you need to. It's going to be a subtraction process. I would subtract out how many milliliters of solution I started with from how much I'm making in the end, okay? And that is going to give me 86 milliliters of water. So the moral to this problem is, sometimes we love to work through a problem and get to the equal, which was this, and say, I'm done, and then look for that answer if it's a multiple choice question. But what you really need to get in the habit of doing when you get finished and you get to the equal sign is go back and read the question and say, have I answered what it asked? It's asking for water. Is this water? No, it's not. So I need to do a little bit more. It's just so common not to finish a problem once you get the equal all figured out. Okay, so we now know molarity. We now know how to do dilution problems. Our next lesson that you'll watch will have us combining this information of molarity into the world of stoichiometry.